Merry Christmas! Let's get into the holiday spirit by doing some physics practice problems. Alright, so when we have multiple forces acting on an object, the net force is going to be all of the vectors of those forces added together. So let's kind of do an example where if we have this angled force and this downward force on this object, the magnitude of the net force is going to be these vectors added together, so it'll look something like this. So to add vectors together, we basically put one of their beginnings onto the end of the other one like this, and then the resulting vector is kind of a triangle of kind of forms a triangle with the two, and it's there. It's that one in the middle. And that represents these two vectors added together. When you have more vectors, this will be a little bit more complicated, but it's going to be the same concept of adding the vectors. And so the magnitude is most likely not going to be equal to the magnitude of your two force vectors added together. It will likely be smaller than that unless the two force vectors are going in the exact same direction. And we can calculate this with some trigonometry, but this isn't really relevant to this problem. It's a little bit more complicated, but essentially to find the magnitude or direction, we would just do some trig stuff or just add the individual components of the vectors together to make our final net force vector. So let's do an example problem. The figure above shows the directions and relative magnitudes of all three forces that are acting on an object. Which of the following best shows the direction of the object's acceleration? So as you can see, we have this object with some forces acting on it. I'll redraw it because I made myself some notes of what the final vector would look like. It looks something like this. So you see there are two forces acting on it on the y-axis, kind of one with a greater magnitude going in the positive upwards direction and one with a lower magnitude going in the downwards direction. And then there's another force acting on it in the x direction, but that's just one. So if we basically stack these two y-axis vectors on top of each other, putting the beginning of one onto the end of the other, we'll get a result something like this. I'll try using a different color pen to draw that new vector that I place over here. So as you can see, I put this vector up here to add it to that one. And we get the combination will be a vector that goes like this. I made it really nice and bold. So from there, we're just adding that last vector in, which is on the x-axis, to the end of that one. I'll do it in another color again. So we basically get that. And then our resulting final net force vector will be the vector which starts at the center of mass of this object and ends at the ending of that last arrow I drew. So let me see if I have another color marker somewhere. Okay, that's good. So it'll be that last blue vector that I just drew, and that is the net force on this object. So it looks like there is an answer which looks pretty similar to that, answer A, on AP test question 23.